It's my great pleasure to announce Daz MacHale, who will give a presentation on the humour of mathematics. Daz is an emeritus professor at University College of Cork. He has an honorary doctorate in literature for his books on George Boole, who Daz has written on multiple times, and he's a well accomplished author with over 60 books, and I could not do him justice or honor introducing him, so I will just pass over to him directly. And so please welcome Daz MacHale.
So greetings to you all from Cork in Ireland. I've been interested in mathematics ever since I was a child. My mother told me that when I was about 5, I would ask everyone in the house how many potatoes they wanted for dinner and present the results to her on a little chart. When I used to help my father in the garden, I would lay down the cabbage plants all parallel to each other, all the same distance apart, all the same distance above the soil. My party piece was to recite very quickly 1 + 1 = 2, 2 + 2 = 4, 4 + 4 = 8, 8 + 8 = 16, 16 + 16 = 32, 32 + 32 = 64, etc. I must have been an unbearable little mathematical nerd. But my interest in the powers of 2 remains to this day. Recently, I've been looking at this problem. Is there a biggest power of 2 which does not contain a 0 in its decimal expansion? 2 to the power of 86 is the biggest one I can find, and there are none between 2 to the power of 86 and 2 to the power of 50,000. So very probably there are no more, but how on earth would you prove that? Amazingly, in my 77th year, I love mathematics even more now. I compare it to a gold mine where, unlike earthly gold mines, the more you dig, the more gold you find. I really love teaching and miss very much interacting with some of the brightest young people in Ireland, maybe even in the world. But teaching requires a lot of energy, and I am happy to leave all this brain candy to a new generation of teachers. I am intensely interested in problem solving, but I do not feel I am an exceptional problem solver. I've had my moments. If I have a talent, it is for problem creation, which requires adaptation, generalization, and lateral thinking. I set up an examination called the Super Brain at UCC, open to all students of all faculties, and this led to the Irish InterVarsity Mathematicalist examination, open to all Irish third-level colleges and universities. I set all the questions myself and marked them all myself. Both are still going strong. If you Google Super Brain UCC, you will find books with the questions and solutions on the web. Another of my abiding interests is humor, especially jokes. When I was a teenager, I had the ambition to write the world's biggest and best book of jokes. I collected and wrote down every joke I had heard, literally thousands of them. My estimate is that there are about 15 million jokes in existence. Most of them, of course, very poor and weak, just padding in the joke books. I've written a book containing about 300 of what I regard as the greatest jokes of all time. This estimate, of course, is entirely subjective, but I do not believe there are many more. All I get now is a trickle of new great jokes every year. I think I've got most of them. Given my interest, it was probably inevitable that I would be drawn to the humour of mathematics. This is, of course, a non-commutative situation because the humour of mathematics is quite distinct from the mathematics of humour, which looks at mathematical structures occurring in humour and jokes, and involves geometric and vector diagrams explaining the reasons why jokes are funny. Dare I say it, while a very interesting area, it raises very few laughs, though some people find this very area of study an amusing concept in itself, the humour of mathematics. Let me give you one example from Mark Twain. By the way, Mark Twain is one of my very favourite humourists. He's absolutely wonderful humorist. And I discovered recently, to my delight, that he had Irish ancestry, which explains an awful lot. This is Mark Twain's famous quip on the stock market. He says, "February is a very dangerous month in which to speculate in stocks. Other dangerous months are December, April, June, August, January, March, November, May, July, October, and November." Now, if we draw a vector diagram starting with February and a vector coming out from February to December, then a vector to April, then a vector to June, all the way around to a vector ending up at November, and we find we go round in a complete circle. As we go around, we look for pattern and conclusion. We get to November and back to February again, we realize that the sum of the vectors is the zero vector. Twain is just making the observation that it is always dangerous to speculate in stalks. Freud would say the energy we have saved is now expressed in laughter. That's the sort of technical explanation you get when you look at the mathematics of humor, and it's a tricky subject. The problem is important in mathematics. The riddle is important, and it's an ancient form of humor, much loved by children, incidentally. Children absolutely love riddles. Logic is also another connection between mathematics and humor. Mathematics is ultra-logical, whereas humor frequently turns logic on its head. My belief is that most mathematicians have a very good sense of humor, perhaps because they're good at spotting logical mistakes and fallacies. And I can see a strong connection between the joke and the theorem. In the joke, you have introduction of characters. In the theorem, you have hypothesis. In the joke, you have development of plot. In the theorem, you have proof. In the joke, you have punchline. In the theorem, you have result. There is, of course, one important difference. You can reveal a mathematical result beforehand, but not the punchline of a joke without destroying the effect. But maybe a mathematical result should be kept as a surprise too, to come at the end of the mathematical theorem. By the way, there is a strong correlation between intelligence, ability at mathematics, and a sense of humor. There's an excellent article on this in the journal Humour, H-U-M-O-R, an academic publication on all aspects of humor. So some people do take this seriously as far as pedagogy and education is concerned. I've put together what I regard, I modestly claim, is the definitive collection of mathematical jokes, humor, wit, and wisdom with the punny title Comic Sections. It's just been published. Comic Sections Plus, it's called. And here's what the book looks like. If you want to have a look at it. That fellow, by the way, on the cover, I've called him a silly cone called Chip. That's his name. It's been published by Logic Press here in Ireland, which is run by Professor Tony O'Farrell, a mathematician who was Emeritus Professor of Mathematics at Maynooth University. And he's very worthy of your support because almost single-handedly, he gives you some fantastic mathematical books. And I think he's somebody you should support. If you look at the web at logicpress.com, you'll see his publications. Now, let me also remind you of the names of some people who were humorous mathematicians, mathematical humorists, or who had a foot in both camps. There was Lewis Carroll, real name Charles Lutwidge Dodgson, the author of Alice in Wonderland. He was a lecturer in mathematics at the University of Oxford. There was Stephen Leacock, Canadian, to my mind, one of the funniest writers of all time. He was a mathematical economist. Leo Moser was a mathematician and writer who composed and collected mathematical limericks. Tom Lehrer was a professor at Caltech and left there to become an entertainer. He wrote some wonderfully funny mathematical songs, including Lobachevsky. And he also wrote the famous Poisoning Pigeons in the Park. Even the serious Charles Babbage of computer fame collected jokes with a view to analyzing what made them funny. James Clerk Maxwell, to me, one of the greatest geniuses of all time, had a fine sense of humor too. And sadly, we recently lost to COVID John Horton Conway, a great mathematician with an impish sense of humor in his work and life. Now, you'll notice that shortlist is all male, and I'm not aware of any female mathematicians involved in humor, and I would welcome information on that topic and be happy to add their names to my list if any of you happen to know any funny mathematical girls. The stereotype we suffer from in the joke books is that of the absent-minded mathematician, though in reality, one rarely meets with such individuals. Perhaps it is a backhanded compliment. We are so concerned with our wonderful subject that we forget about everything else, especially the practical details of everyday living. Most of these stories have attached themselves to a very brilliant mathematician, Norbert Wiener, who lived from 1894 to 1964, professor of mathematics at MIT and the father of cybernetics, a very, very brilliant individual indeed. But here are some of the stories that have attached themselves to him. He was once seen going round and round in a revolving door, unable to remember if he was entering or leaving the building. He was once stopped by a student on campus who asked him a very interesting mathematical question, so he stopped and discussed with him and gave him a very good answer. When he's finished, he said to the student, "Which direction was I pointed in when you stopped me?" "That way," said the student, pointing towards his office. "Good," said Wiener. "That means I've had my lunch." Several stories of him going by train and losing his ticket and trying to explain to the conductor what the situation was. The conductor saying, "Well, it's okay. We know you're honest. We know you're not trying to cheat the railway." He says, "No, but you don't understand. If I don't have my ticket, I don't know where I'm going." And of course, drove over to a nearby university in his car. When he came out after the seminar, forgot completely what his car looked like, what the make was, what the color was, but he had a good mathematical algorithm. He waited until all the other cars had left the car park and deduced that the one remaining had to be his. But the best Wiener story is the time the family moved house. His wife gave the new address on a sheet of paper and said, you know, don't come back here, come back to the new address tonight when you come home from work. Of course, he lost the sheet of paper, came back to his old, forgot what was on it, came back to his old house, and seeing the house empty, seeing a little boy nearby, he said, young fellow, can you tell me where the Wieners have gone? Yes, Daddy, said the little boy. Mummy sent me to show you the way to our new house. And it does actually appear as if some of these stories are true, but he is the stereotype of the absent-minded mathematician. My experience among mathematicians I've met is of people with a keen sense of humor, but their reputation, sadly, is one of dullness and social incompetence. Some of you may have heard the joke about the difference between an introvert mathematician and an extrovert mathematician. Well, when the introvert mathematician is talking to you, he looks at his shoes. But when the extrovert mathematician is talking to you, he looks at your shoes. Now that's progress. An applied mathematician was in court giving evidence in a murder case, and he had to bring in Newton's law of cooling as to when the body the person had actually been killed and what the temperature of the body was. So the judge said to him, how would you describe yourself? And he said, I am the world's greatest expert on partial differential equations. The judge said, isn't that a bit immodest of you? And the applied mathematician says, you must remember I'm on oath. And I love that. There's beautiful consistency in there. There's a character in Ireland called the brother, a sort of prototype character who doesn't care very much about the norms of society. And there's a story about the brother in a car being instructed how to drive by a driving instructor. And the first thing he does is he drives at a huge speed through a red light. And the instructor says, oh my God, why on earth did you do that? You're going to kill us. He says, look, my brother says, go through red lights and you'll be fine. So they come to the next light, again it's red, and he runs right through the red light. The instructor says, you're going to kill me if you continue like this. He says, no, the brother says it's fine to go through red lights. Then they come to a green light, and the brother stops, jams on the brakes, and nearly sends the instructor out to the front window. He said, what on earth did you pull up there for? And he says, the brother might be coming the other way. And I just love that story because it's completely consistent. He and the guy taking the lesson and the brother have a system that's absolutely correct and consistent, but it's inconsistent with what the rest of us do. Now, when you're doing truth tables in logic, you can swap the 1 and the 0 and still get a consistent system. But everybody must agree on this beforehand, and everybody must have the same interpretation of 1 and the same interpretation of 0, or we're going to have total chaos. And I think there's a very interesting lesson in logic and mathematics there. It doesn't matter what your symbols are, it doesn't matter what your rules and regulations are, as long as everybody agrees with them and believes them at the same time. There's a story of a mathematician correcting a mathematical paper, and it's a completely blank answer book, except for one line of writing, and the student has written Macbeth, Act 2, Scene 5, line 28. So the examiner goes to his collected Shakespeare and has a quick look and see what on earth the student means by this. And the line he's quoted, Macbeth, Act 2, Scene 5, line 28 is, I cannot do the bloody thing. And I like that one. There's a story of a mathematician who fell in hard times and had to give tuition, had to make his living by giving tuition to individual students. So one student came to him looking for tuition and he said, how much is it going to cost me? He says, it's going to cost you $100 an hour. He says, that's a bit steep, isn't it? That $100 an hour for mathematical tuition. And the mathematician says, I also give lessons at $20 an hour, but I wouldn't recommend them. And I think that's a lovely story because there's anybody who ever teaches mathematics, I think, puts at whatever level, puts their heart and soul into actually doing their very, very best. And that's just funny because it's totally inconsistent with reality. A friend of mine, Glenn Thomas, who taught us in Cork for some time, and he tells me this story is true. He was at a conference in Germany, and there was a professor there who was sitting in the lecture hall, and he had a great big book. He had a thesis, and he was tearing sheets out of the thesis and writing on the back, make sure you pay for your coffee money, make sure that you get get your tickets for the bus and everything else. And he was wondering what was going on. So he said to him, "Is that a thesis you've got there?" "Yes." He says, "It's one of my students' theses." He said he could have 12 copies printed for almost nothing, and I took 12 copies. "And is it a good thesis?" "Oh, it's a very good thesis." "And what's your definition of a good thesis?" "Well, a good thesis is one which is written on one side of the paper only." And I like that, the contempt is there. There is the scientific hierarchy. Biologists think they are biochemists. Biochemists think they are chemists. Chemists think they are physical chemists. Physical chemists think they are physicists. And physicists think they are God. And God thinks he's a mathematician. We all know the Hardy-Ramanujan story about the taxi number 1729, that 10 cubed plus 9 cubed equals 12 cubed plus 1 cubed, and that's the smallest number expressible as the sum of two cubes in two different ways. Here's a nice variation. As Hardy lay dying, he was visited by his friend Littlewood. He told Hardy, "The number of the taxi I came in was rather uninteresting. It was 14. Hardy raised himself from his deathbed and said, "On the contrary, my dear Littlewood, 14 is a very interesting number. It is the smallest number that can be expressed as the product of 2 and 7 in two different ways." Now, that's actually a meta joke. If you haven't heard the first joke, that jokes make no sense whatsoever, and you don't think it's funny. But I think if you have heard the first joke, the Hardy-Ramanujan joke, then it's a very funny joke. There was a young PhD student speaking at a conference, and he was talking about his research, and he had a fantastic theorem that he had proved, and he was just putting it up on the board, when an experienced mathematician in the audience stood up and says, "I'm sorry, I think I have a counterexample to your theorem." And the student said, "That's okay, I have another proof." Now, I've told that to some students, and they don't laugh, they don't find it funny, and I worry about them if they don't find it funny. There's the great story about a lawyer, a poet, and a mathematician all discussing whether it's better to have a wife or to have a mistress. And the lawyer said, "It's better to have a wife because that's all legal. And if there's any argument or any row or breakup, everything is covered by the law." The poet says, "Look, wives are dull, mistresses are exciting. You're much better to have a mistress than a wife." And the mathematician says, "Well, I think it's better to have both, because then you can spend, you can tell your wife you're spending all night with your mistress, you can tell your mistress you're spending all night with your wife, and you can spend the whole night doing mathematics." There's somebody who's got his priorities right. Now, I want to read you something. It's actually in my book, but I find this unbearably funny. Now, maybe you won't find it unbearably funny, but I think it's extremely funny. It's called Dead Reckoning, and it seems it's a recognized navigational technique when you're at sea for those who find themselves lost at sea. But I find this account very, very funny indeed. Dead reckoning can tell you where you are at any given time, and it operates on the principle that if you know where you were, and if you know where you have gone, then by extrapolating from where you were and where you have gone, you can calculate where you are, or at least where you were when you originally started calculating. Since the position where you are now is not the position that you calculated, and the position that you were in is not the position that you're in now, it follows that you have introduced an error. This is defined as the difference between where you are and where you aren't, but calculated you should be. This error can be minimized by calculating the next position that you now aren't in because you have just moved. Unfortunately, you still have an error, but by this method, the error does not compound itself, giving rise to an accurate estimate of the position where you are not. If the wind and the tide are not equal and opposite, then a calculation must be made which takes into account their cumulative force and direction. It is important to remember, however, that the time interval is the time from where you were to where you no longer are. This calculation results in a correction that should be applied to the position where you are not in order to genuinely ascertain where you still are not. And then it says, this is the same method as used by Christopher Columbus when he set out to find India, but discover America instead. No wonder. That is an authentic extract from a sailing manual, which tries to instruct people on the process of dead reckoning. There was a mathematician called Paul Dirac. He was a physicist also. He was a very brilliant mathematician and physicist, and he won a Nobel Prize for physics. But he went back to his old school in Bristol in the UK, and after he'd given a very good talk, the headmaster said, Professor Dirac has now kindly agreed to answer any questions you may have. One student raised his hand and said, Professor Dirac, I didn't understand a single word of your lecture. Dirac completely ignored him. went on to somebody else. And afterwards, the headmaster says, why did you ignore that student's question? And Reg says, that wasn't a question. That was a statement of fact. It's very nice. Now, there are many other aspects of mathematical humor, and I'll go through some of them fairly quickly. One is limericks in verse. There are many thousands of limericks, and there are certainly a few dozen of them mathematical. Here are a few. There was a young fellow called Guesser, whose knowledge grew lesser and lesser, till finally one day it vanished away. He's now a mathematics professor. A mathematician called Klein thought the Mobius strip was divine, and he said if you glue the end edges in two, you'll get a weird bottle like mine. A mathematician confided that a Mobius strip is one-sided, and he said with a laugh, if you cut it in half, it stays in one piece when divided. And in my opinion, the best of all limericks, told to me by David Singmaster, whom I'm sure many of you know and admire. A question both deep and profound is whether a circle is round. In a paper of Erdos, written in Kurdish, a counterexample is found. Is that lovely? Stems perfectly. There are many other verse forms with mathematical content. For example, a couplet of tribute to W.H. Auden, who was a famous poet, certainly not a mathematician. And he wrote, minus times minus is equal to plus. The reasons for this we need not discuss. There is also the Clerihew, another wonderful verse form due to E.C. Bentley, 1875 to 1956. And he composed a wonderful Clerihew. I quite realize, said Columbus, that the earth is not a rhombus, but I'm a little annoyed to find it's an oblate spheroid. And also, James Clerk Maxwell could not play the sax well, but there were many raves for his electromagnetic waves. And rather topically, I'm afraid, Isaac Newton was a bit like Putin. He caused many ructions with his theory of fluxions. Carl Friedrich Gauss always slept in a house because number theory made him exceedingly weary. And a final limerick about my hero, George Boole. Though it's many a year since Boole died, his work is still known far and wide. And believe it or not, it's still used quite a lot wherever computers reside. I'd like now to turn to what we call howlers or boners. Some of the best mathematical humor, in my opinion, arise from mistakes that inexperienced students make. Our lofty intellects would not allow us to make such mistakes, and we feel quite superior, so we laugh. But we must admit that some of these mistakes contain a touch of genius, creative and poetic. Here are some authentic ones, many collected by myself from examination papers. Show you a little slide now. 8 over 0 equals infinity implies 3 over 0 equals omega. None of us would be capable of making a mistake of that magnitude. I think there's a touch of genius about that, and I admire it very much. And there's also cancellation. Cancellation is the bane of many teachers. Students just don't seem to have got there. And here is a wonderful example of cancellation. Sine x over n. Cancel the n's. What do you get? 6. Now, that is genius. I don't think any of us would be capable of doing something like that. Here's a question from an examination. Show that C, the cardinal of the continuum, is greater than L of 0, the cardinal of the natural numbers. And the answer given was, C is the velocity of light. Nothing can travel faster than light. Therefore, C is greater than L of 0. Isn't that absolutely wonderful? In the equation, E equals h nu, give the interpretation of each symbol. And the student had E is the energy, h is Planck's constant, all correct, and nu is the length of the Planck. Isn't that wonderful? However, there is the universal law of student cancellation. That means if the same symbol x occurs in 2 different places on the same page, then it may be cancelled. And I think a lot of students come very close to that. However, we can turn mistakes to our advantage. The student writes 1 over x plus y is 1 over x plus 1 over y. We can ask, for what numbers is that true? Show it's not true for any real numbers. Show it can be true for complex numbers. When is x plus y to be squared equals x squared plus y squared? Well, there are rings in which that actually happens. So we can use student mistakes as teaching aids. Now, I've written several books of ethnic jokes, which unfortunately are not PC nowadays, and one has to be very careful in case. So I apologize in advance if I'm going to offend anybody, but I hope I won't. But since I'm Irish, and we are well known for being able to laugh at ourselves, I've made the Irish the fall guys in all of these jokes. Many of these jokes have mathematical content, Elementary, admittedly, but there's some mathematical content there. To understand them and to laugh, you need to understand some mathematics. For example, an Irishman rushes into a railway station and says to the clerk, "Could I have a return ticket, please?" "Where to?" asked the clerk. "Why, back to here, you fool," says the Irishman. On the mathematical content there, if you take v plus minus v equals 0 for vectors v, that's independent of the vector v. It doesn't matter. How many Irishmen does it take to milk a cow? Well, the answer is 24. 1 to hold each teat and 20 to lift the cow up and down. And that's surely a joke about relative motion. There's a joke called the compensation joke, which is an absolute classic, and some people have voted this as one of the greatest jokes of all time. One Irishman has explained to another how nature sometimes compensates for our deficiencies, that if a man has a poor sense of smell, he may have a good sense of taste. If his eyes are weak, maybe his ears will be strong. The other Irishman says, "I think I understand what you mean now. I've often noticed if somebody has one short leg, the other one is always just a little bit longer." Now, is that just A greater than B if and only if B is less than A? And that shows you can make a joke out of the very simplest mathematical relation. There's one very important joke in this context, and that's the reason why I'm talking about ethnic jokes, and I think it has serious mathematical content. An Irishman captures a leprechaun and asks for the usual 3 wishes before releasing him. If you capture a leprechaun, these little fairy men, you have 3 wishes before you release them. The leprechaun agrees and says that 1 wish has already been granted, the fact that he's granted them the wishes. So there's a bit of logic difficulty there. Then the Irishman asks for a purse of gold coins, so that no matter how many he takes out, removes them from the purse, some will remain. And this wish is granted. They then agree to meet a week later for his 3rd wish. When they do, the Irishman says, "That's a wonderful purse entirely. For my 3rd wish, I'll have another one of those purses, please." Okay, that's a joke. But what does it depend on? It depends on the person listening has the knowledge that one of these purses is exactly the same effect as 2 of these purses. And I think it's the union of 2 countable sets is a countable set. And this was way before Cantor. So Galileo had a similar idea way before that. So sometimes a joke can have very serious mathematical content. By the way, if I was there, if I'd captured the leprechaun, I'd ask for as many wishes as I possibly wanted as my 2nd wish. Would that have worked? Is that a valid wish? And again, now you're into meta levels there. Another category of mathematical humor, which I'm very interested in, is graffiti. And I spell that Graphiti. It's the writing on the wall, and probably the only form of publication open to many mathematicians nowadays, especially undergraduates. Here's some examples of things that have been written on walls in mathematics departments. Most universities have a mathematics department because that's cheaper than institutionalizing all those people. And some of the places I've worked would fit there. Algebra is a bit like divorce. You look at your ex and you wonder why. The theory of relativity means that time spent with your relatives seems longer. The square root of 4b squared, is that 2b or not 2b? The principle of Occam's razor is that Bertrand Russell shaves everyone who doesn't shave himself. Is no the answer to this question? That's a difficult one. Try and answer it. Mathematical analysis is an area of mathematics where you spend half your time proving that x is greater than or equal to y, and the other half proving that y is greater than or equal to x, when all along you know that y is equal to x. And infinity is just 0 with a twist. Take your 0, give it a twist, and you get infinity. And so on, and so on, and so on. Now, I'd like to turn to some reviews from the journals. Mathematicians can be quite bitchy when reviewing other people's papers in books and journals. This is perhaps the only time you get a chance to say what you really feel about your colleagues. Here are some of the funniest to them. This one takes some beating. Not alone is the principal and only theorem in this paper absolutely false, but the example quoted to illustrate it is in fact a counterexample. I love that. This paper contains many new and interesting results. Unfortunately, the results that are new are not interesting, and the results that are interesting are not new. From a review of a book called Ignorance in Mathematics, the author has contributed greatly to his subject. The author discusses valueless measures in pointless spaces. The main theorem is true. However, only the identity function acting on the trivial space satisfies the hypothesis. One of my favorites from a very critical review of a new textbook, the printing and binding of this book are excellent. Now, I talked earlier about the connection between the question in mathematics and the riddle in humour, and they're closely linked, each asking a question which needs an answer, and sometimes the answer is unexpected and surprising. It's very nice when a piece of mathematics asks the question and the answer is totally unexpected. Particularly interesting is a riddle with mathematical content, and there are many of these very popular with mathematical undergraduates. For example, what is purple and commutative? Well, it's an abelian grape. What is yellow and equivalent to the axiom of choice? Someone's lemon. And why did the complex analyst call his dog Koshi? Because he left a residue at every pole. What do you get if you cross a mosquito and a mountain climber? Nothing. You can't cross a vector and a scalar. That's a beauty. Why do computer scientists confuse Halloween and Christmas? Because Oct 31 equals December Des 25. What's the volume of a cylindrical savory cake of radius Z and height A? The answer is pizza. That's pi Z squared A. What goes pieces of 7, pieces of 7? That's a parity error. And can a 2-year-old boy learn trigonometry? Of course he can't. So there's a lot of clever things there. Why did the chicken cross the Mobius band? To get to the other, Why did the mathematician use his job at the meteorological office? He thought that FOG was the composition of functions. And this probably is my favorite one. Which number in the following sequence is the odd one out? 11, 13, 16, 17, 20, 23, 24, 27, 32. Can you see it? The answer is 24, of course, because all the others come with fried rice. Obvious. I'd like to finish now with talking about the wit and wisdom of mathematics. My basic interest in the humour of mathematics is because I believe that if skillfully used, and that's a very important caveat, it humanises the subject, makes it more enjoyable, and leads to a greater understanding. We should listen to what the great mathematicians of history have said. My book contains over 700 quotations and aphorisms, which I consider wise and witty, and that I think we all could benefit from, students, teachers, and researchers. Here are some of my favorites. Applied mathematics will always need pure mathematics, just as an anteater will always need ants. That's by Paul Halmosh, very famous mathematician. In ancient times, they had no statistics, so they had to fall back on lies. That's Stephen Leacock, again, one of my very favorite writers. The moving power of mathematical invention is not reasoning, but imagination. That's Augustus de Morgan. If a man has $100 and you leave him with $2, that's subtraction. And that's the great Mae West. She should know. I could be bounded in a nutshell and count myself king of infinite space. That's what Hamlet said. William Shakespeare wrote that. And that shows profound insight into the nature of countable sets, uncountable sets, the universe in a nutshell. Perhaps you've been reading Measure for Measure at the time. I was too good for philosophy and not good enough for physics. Mathematics is in between. That's what the great George Boole said. You can find truth with logic only if you have found truth without it. That's what G.K. Chesterton said. A hunch is creativity trying to tell you something. That's Frank Capra. Results? Why, man, I have gotten a lot of results. I know thousands of things that do not work. That's Thomas Edison. A lovely story told about Edison when he was receiving an award. There was a column in the book he had to sign which said, interested in. And he wrote down, everything. I just love that. You can be interested in everything. You can get information, you can get knowledge, you can get insight from any human area of knowledge. Gambling is a sure way of getting nothing for something. That's Wilson Minsner. If you cannot solve a problem, there is an easier problem you cannot solve. Find it. That's George Boole again. And my final offering to you, and we've all known this mathematician in our own lives. too intense contemplation of his own genius had begun to undermine his health. That's the great Max Beerbohm. So thank you very much for your attention, and thank you especially to Tiago and Colm for all the technical help they've given me, and I hope you got something to think about in my presentation.
This was a very, very beautiful presentation. Brilliant. People are already commenting that they couldn't stop laughing.
Did you become interested in George Boole's life because of Boolean rings, or was it the other way around?
I taught at University College Cork, and he was the first professor of mathematics there. And when I arrived, I just heard about Boole, and there was a gentleman doing his thesis on the history of UCC, of the college, and he discovered some letters of Boole in the archives, and he said, well, I'd like to look at them. I said, I'd love to look at them, and I did. And I started writing a little short paper, which became a long paper, which became a short book, which became a full-length book. So I was just in the place where Boole had been, and nobody had really done any work on him. But I am interested in Boolean rings. I am interested in commutative systems and ring theory. So I had an algebraic interest as well as a historical interest.
From the chat, we have another question. Do you have anything funny from Sir Roger Penrose?
I met Sir Roger Penrose. He was actually at our conference. We had a conference on humour in University College Cork in 1984 or something like that. And Roger Penrose was there, and he was also at a conference on Boole, and he was talking about Boole, and I actually met him. But I found him now a serious individual. He was I don't remember any particular. Of course, I may not have got him in a humorous mood, but I found him serious. But a very interesting man, a very nice man, a very modest man, and a very approachable man. Hasn't he won the Nobel Prize at some stage? I mean, for physics. So he's a very modest man, and he was debating with McCarthy, with John McCarthy, is a very interesting topic. I mean, is the human brain, is it just nuts and bolts, or is there something more there? And at the time, the press thought he was actually looking for, where is the spirit, if it exists, or the soul located within the physical body, which is a very interesting topic. And McCarthy was saying, no, look, the human body is just nuts and bolts. It's like a computer, and it processes information, and that's it. Penrose was saying, look, there's something more there. There's something in the human spirit which is greater than the sum of its parts. Very interesting. But I don't remember an awful lot of humor. But maybe there wasn't. Did I say he came to the conference in humor? No, I think it was the Boole conference he came to. So he wouldn't have had a chance of actually being humorous.
There's also follow-up by Colin Wright, I believe, on the limerick on Emeritus. So Emeritus apparently, upon hearing the limerick, went hunting for a journal in Kurdish so he could publish it.
That's correct, but there is no journal in Kurdish. Yeah, that's very true. It's a lovely limerick. I mean, as a question both deep and profound as whether a circle is round. In the theorem of Erdos, written in Kurdish, a counterexample is found. You just keep wondering what the counterexample will be of a non-round circle. It's a lovely image. But the best limericks are ones that scan the best. So Tony O'Farrell has been very good to sort of scanning some of the limericks I gave me. They have to scan properly before they're effective. You really got to do that.
I thank everyone for the participation, and I would like also to put in a big thank you for this beautiful and very informative and, well, very funny presentation. And citing Victor Jules, thank you so much, Des, for
thank you to all my audience
for creating the shortest link between two people, which is laughter.
Good.